Oh, well, hello. There you are. Hey, I just wanted to take a quick moment to say thank you. Thank you for hanging out till episode 6. Thank you for being awesome and learning C#. I hope you're having a good time. We're going to make something awesome. And if you would, if you're liking what you're seeing, give me a subscription, give me a like, give me a comment, hit that bell so you know when the next one's coming. Let's get started. Okay, guys, so before we get started doing anything, we're going to do what I said at the end of last series. We're going to make a new branch so we can work off of that branch. And you guys can come along and on episode 6 and just grab the source code in case you miss any other episodes. So to do that, you can see we're on the master branch. It's the only branch there is. You can like Git Branch to see what branch you're on. I'm on the master branch. I'm going to create a branch called episode 6. So Git, and you do Git checkout. B, and we're going to call it episode 6. Why not? Episode 6. Let's go big here. Boop. Git checkout B episode 6. Hit enter. I just switched to a new branch called episode 6. Now I want to push it. So git push origin episode 6. All right, so we created the branch. If we went to GitHub right now and looked at our branches, you can see we now have 2 branches. We have an episode 6 and we have a master. And after I'm done with episode 6, I'll push all the changes into master and then make an episode 7, which will be awesome. Actually, you know what? I'm going to rethink that. We're starting episode 6 and we have all the code that we want for episode 6 start. So this is done. This is finished. And master is caught up because this is where I'm at right now on master. Now, I'm going to create a new branch, actually. I'm going to say git checkout episode 7. There we go. And then git push origin. Whoops. The reason I did that is because we're going to make a lot of changes today, and I don't want them to go into episode 6 because I want someone to grab episode 6 and it would be at the start of the episode. When we're done with this episode, then all of episode 7 is what we'll push into the master, and we'll push into episode 7, and we're done. And that way we're not going to hurt episode 6. Episode 6 will stay pristine forever. So episode 6 is done. We're not going to touch that. And here's episode 7. Perfect. All right, let's go. Okay, so just to recap, at the end of episode 4, we made a game service. We moved all the game stuff, beginning game stuff, into game service, into the start game method. This is where we grabbed the adventure file and we loaded it in, and we had our initial adventure. Now, before we go any farther, I want to go a little farther down the road and this doesn't actually belong here. Remember the single responsibility principle. It says class should have one reason for existing, one reason for changing. This has got adventure stuff in it. If the adventure stuff ever changes and game stuff ever changes, and there's really one thing that will absolutely always happen when you program, and that is change. Change is always going to happen. So you have to expect change. So let's get this adventure stuff in its own class. Now, before we start that, I want to introduce you to the 4 pillars of object-oriented programming. The 4 pillars of object-oriented programming are, I like this definition on LinkedIn. I'll put these links below. Abstraction. Basically, that's where you create your classes. Basically, we're creating classes, adventures, characters, that sort of thing. Encapsulation, that's where you hide the details. You make stuff private, you make stuff public. We've talked about that. Now, the third part is inheritance. That's where things can inherit from each other. My daughter is a type of human. That's a terrible example. There's a car. You can create a car class, and then you can create a Toyota. Let's say you create a bird class, and so something like this. Bird does these few things, and then we can create child classes. We could say, hey, let's make a class called Mallard Duck, and it inherits. So there's a colon from bird. Right, and you see it says that it inherits, and it's a new class. So basically, a mallard duck can do anything that a bird can do because it inherited from that. We're saying, hey, a mallard duck is a bird, right? So we could create a new class that called using birds, and we could call our new mallard duck that we've made. Now, if I was to say, hey, mduck, you'll notice that mduck Actually, let me make a constructor. Now, if I want to call my mduck, you'll notice that it has fly, is flying, and wings because it inherited from bird. So we just used inheritance there. Problem arises, though, when we try to do this too much. We try to make things, we try to overuse inheritance to make things work for all kinds of situations. So, you know, another bird is a little toy bird, right? You got a toy bird. It's also a bird. It's a bird. It's a toy, but it's a bird. The problem is it doesn't just fly the same way that a mallard duck flies. It flies, it has to be turned on. So with toy bird, you would have to like give it a special attribute that says it's turned on and can you fly and blah, 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 blah. So this is inheritance. It's powerful, but it's also troublesome. A way to get around that is to look at the third principle in solid, our 5 major principles for programming. The Liskov Substitution Principle. We already talked about the single responsibility principle. We just spoke about that a second ago. This is the Liskov Substitution Principle. Basically, it states that if you're going to use inheritance, you're going to use, you're going to say that something is a part of something else, that it better be able to be used by anything. Otherwise, if it has to be specific, you're breaking the principle. You're going to have problems in the end. Plus, you can't test. It's just a big mess. So, C#'s remedy is a thing called an interface. Rather than making a hard, solid class of something to be inherited from, we make things called interfaces, which are basically agreements. It's not really a thing. It's saying this is an agreement to use these things. I mentioned all that because I want to get rid of, or I want to start using interfaces so that we can get into unit testing in a little bit. So I'm going to go over to my adventure folder. And in all our adventure stuff, I'm going to create a folder called interfaces. These will be all the contracts or the interfaces of the things that we're going to use. So the first thing we're going to need here in interfaces is an interface. You call it, it's a CS file, but it's going to be an interface. We're going to call it the Adventure Service Interface. And the way you name those, the code convention that Microsoft has always used is to put an I before your interfaces. So this is going to be called I Adventure Service. All right, so this is not a class. It is an interface. It needs to be public so we can use it. And it's I Adventure Service. All this is going to do is to tell us if we're going to call something an adventure service, we have to use whatever we define here. This will be a lot clearer when we start unit testing. Just stick with me. Just listen to me. If you're a kind of learner that I am, where you kind of break down unless you understand it, try to get past that and just listen. So what are we going to need for adventure service? Well, we already have a real adventure service program. We already have an adventure service type of thing that's happening. It's basically it's getting the initial adventure, right? That's the thing we want to do, is get initial adventure. So let's create a get adventure, and it will return an adventure. So we will call it get initial adventure. Now, this is the way you write things for interfaces. It's almost like you're writing a method, but you don't have to put public or private or anything like that, because this isn't about, this is just telling the user of iAdventure what they got to provide. They have to provide a method called get initial adventure, and it needs to return an adventure. That's all you need to do. And there's no arguments that need to be sent in, because if it's the initial adventure, we know what they want. So I'm going to save that. Let's go over here to our adventure service. I pushed the little thumb button down so it comes over here. I like it better. I like to actually keep this stuff in order of the way it's being used. It helps my brain. So programs is the first thing that comes in. It calls game service. We're going to have an iAdventure service interface, and then we're going to have the adventure service that will inherit from that. So we come over here to the adventure service. We make it public so we can call it. And at the end, this is how we do inheritance, right? Adventure service. All right, so there we go. We're great, right? No, we have squigglies. We have the red squigglies. So if we hover over the red squigglies, this is going to tell us something important. It says, hey, this adventure service does not implement the interface. You're not following the rules, right? Because remember, what I said was the interfaces tell you how to become one of these things. If you're going to say you're an iAdventure service, then you have to provide all these things, which is only one. So we have to make this method. So we're going to say, okay, all right, I'm listening to you. So public, because now this is an actual implementation of adventure service. Public, and it's returning an adventure, right? And it has to be called Git Adventure, and that gives us the help right there. And we know it doesn't need any arguments, and it's still not working because we haven't returned an adventure. We could just say return new adventure, which would be dumb because that'd be a blank adventure, but that still fulfills the contract. Or does it? I'm doing something wrong here. So here's our light bulb. Let's do this. Light bulb says implement interface. So it can say, hey, let me help you out. I'm going to do what you're missing. So it hits implement internet. Oh, there we go. I named it wrong. So let's get rid of that. Get initial adventure is what the contract says. So yes, this is still complaining because I didn't name this right. Get initial adventure. There we go. Now we have fulfilled the contract and it's happy. It doesn't care what we're doing in here. It doesn't care that I'm doing nothing but sending a blank adventure. It only knows that I'm fulfilling the contract. If I was to say, hey, I want you to send a number in, int send this, it's going to break again because it didn't tell you to send that. It said send nothing. And if I try to return something different, like a string or a string, gonna break again. It's gonna say, bro, do what I told you to do if you're gonna use me. So there we go. So now that we're using a contract or an interface, these can be popped in and substituted, and we can make tests, and we can do unit tests and see if our code and our logic is working right later on. So there you go. Good job. So how does this help us? Well, I'm gonna get rid of this now. I'm gonna go back to game service, and I'm gonna get all of this adventure stuff out of here because it's not adventure stuff. And I'm gonna put it in here. Is that good enough? No, it's not good enough. Why? Well, first of all, we don't have files, so we're going to say use system.io. And we need the JSON, Newtonsoft JSON. And it's still broken. Why is it still broken? Because we're not returning an adventure. We've made initial adventure. There it is. And so here, you know what? I'm going to get rid of this stuff because this isn't adventure stuff, really. This is more of game things. So I'm going to take this back here. I'm going to put this in my start game. And now I'm going to say, right here, I'm going to return that initial adventure to the caller. Now everything is beautiful again. I got these usings I'm not using, so I'll right click and say remove and sort. Very nice, very clean class. Using a contract, very awesome. So over here in game service, I can now call this contract. I'm gonna make this private because this is just game services adventure service. I'm going to say private. Now watch this. iAdventure service. I'm not calling the adventure service. I'm calling iAdventure service, which means when I go to create this, I can pop in anything I want. This makes it more flexible because I can. Maybe I don't want to use this exact one. Maybe this is adventure service for medieval adventures. I don't know. And this does a number of things differently than a class that would be adventure service for space, for sci-fi. Quick example. But because I'm calling out the contract, I don't care what you pop in here. You can pop in anything as long as you're fulfilling that contract. Then I'm going to know inside of this class, and I'm pointing all over the place, guys. I'm going to know inside of this class that you've promised to use the things you say you promised. If it's in here, if it's in the iAdventure service contract, you've promised to use it. So I'm going to give it a name. I'm going to say adventure service. And now because I want you to send me in a iAdventure service, what do I need to have? What do I need to make? A constructor, correct. Remember, we always make constructors when we make classes. The default constructor is just an empty set of arguments. So this is what always happens without us doing it. That happens no matter what. But when we want someone to send us something in, then we have to create a constructor with those things we want sent in, and we want an iAdventure service sent in. And so when someone makes game service outside of this class, when they make a game service, they need to send us in iAdventure service. So I'm going to say my private adventure service now equals adventure service. The one that you're going to send in to me, I'm going to assign it to this. So now we have an adventure service. Now I can come down here and say get initial adventure. I don't have any arguments. Remember, there's no arguments. And I need to assign this to a variable. What should I assign it to? Well, I've already got initial adventure down here, even though I haven't done anything with it. So I'm going to call it that. So I'm going to say var initial adventure equals, and kaplow. We got ourselves contract. Nothing in here at all talks about this class, right? Everything is aiming to this. So if I go back over to my program, which I now have to do, you'll notice game service is now broken because I made it to where you have to send in an adventure service. Now I can send in anything I want. I can have my sci-fi adventure service. I could have my medieval service. We could have something out here. Let's say we're going to make a game service, but we can wait and base upon what type of games they want to play. Do you want to play sci-fi games? You want to play medieval games? Whatever. Blah, blah, blah. So let's make an adventure service. We only have one. Well, in this area, we'll make the actual concrete adventure service that we have. But when we make unit tests, we can create mock-ups of an adventure service so that we can test things. Again, just stick with me. So I'm going to make the actual adventure service. And this is a real live adventure service. I'm going to new it up. It equals a new one, so we have an actual hard adventure service, and I'm going to send that in here. Blam. Blammo. All right. Now we're ready to start. We are set up to unit test in the future, and we are separating our concerns. So this should all be working. Let's run it and make sure it all works the same. Don't need this stuff anymore. There it is. Everything worked just the same as it did before. And we have inheritance. We have contracts. We have Liskov Principle. We're cooking with oil. So guys, now that we have the basic flow down, let's make a lot of the things that we need. We have adventure. We have game. What else do we need? We need entities. Entities, not characters, because we might have monsters, right? We might have, I don't know, some other type of entity. I know monsters and characters are two things that we want, so I'm going to call it entities. That's what I'm going to call it. I made a folder called entities. I'm going to make a folder inside of entities called interfaces for the hard classes we're going to make here. I'm going to make a folder inside of here called models. I like this methodology. So the interface is the contract. The actual implementation is the model. So let's get started with our big model, our most important model of all time. New class. We'll go class. The character. The player. That's a great model. What's the character going to need? Character's going to need a whole bunch of attributes. He or she is going to need to be public. Let's throw some attributes out there. They're going to have a public string name, of course. No, bad word. Public int. What level are they? Public int. Very important how much gold they have. Public. We'll say string. There's probably a better way of doing this. Description? I don't know. Background? I don't know. I'm just spitballing here, people. Public. Inventory? Yeah, we'll go wait. Inventory wait. Okay. Let's make a new class for all the attributes. If you ever played RPGs, you need strength, dexterity, all that. So we'll create a new class called abilities or attributes. No, you know what? I like abilities. Come out here because it is abilities, not public class abilities. Oops. And what would that be? You'd have a public int strength. Wait, vey. Public int dexterity. Public int Constitution of the United States. Public int intelligence. Public int wisdom. Public int charisma. Sweet. Now that we made that class, we can go up here and we can say, you got your name, you got your levels, you got, I like to put these in order. You got your public abilities. Let's think of everything. There's gonna be some things we'll probably need to make new classes for, just like we did abilities, but we don't want to stick it in here. But before we do that, what else could we need? What else could we do? We could say, oh, we could have a list of adventures. No, a list of strings, which would be the adventure goods. So yeah, so we would call those adventures played. This would go with the player's sheet so that we knew whether they played the adventure or not. We could have a Boolean is alive. Armor class. How hard are you to hit? What's your armor class? All right, so I think this leads us into new entities. Not entities, items. New item, an item, a world item, not an entity. Entity, something that's alive, right? So we're going to come down here. We're going to say items. We're going to do our thing, right? We're going to do our interfaces. And our models. Let's make an interface here. Oh, I didn't want to. Yeah, there's. I can use interface. We're going to call it public interface, and this is just going to be an item. If you say you're an item, you're an item. So there we go. We have item. Remember, I is the convention to start off with. And now in our models, we can make an item. Because there might be real items, so we'll do an item class, and it's a public class, and it inherits from item. And that is the wrong spelling. Right off the bat, I can't think of any methods that item is going to need. So this may be unnecessary, but I like to start this way. But I can't think of some attributes. We need a public string description of what the item is, maybe. Public integer objective number. Maybe there's something, this might be something that's used later on in an adventure. That could be a total throwaway. Public integer weight. How much does this weigh? And a public integer gold value. This is kind of describes an item, but I feel like there should be classes or types. Here's what we're going to do. We're going to do what's called an enum. I think we talked about enums. Enum is like a list of things. It's not quite a class. It's not a class at all, but it kind of lists things out easily. So we're going to call this enum item type. So what types of items are there in an adventure? There's rope, there's torches, there's holy symbols. Think of the things you might have in an adventurer's bag. Water, food, tinderbox. I don't know, that's good enough. There's probably a lot more. So then up here, we can tell what type it is. We can say what item type, because that's their enum, and we'll call it a name. So this will say, hey, this is a torch. And we could say it's Todd's cool torch. No objective number because who wants to win a torch? It weighs a half. It weighs 1, whatever we're going to call the weights, and it's worth 1 gold value. All right, so there's that. So now a character. We go back to our character. Now we can say, hey, let's make inventory. And what would inventory be? But a list, right, of, you catching on? items. Inventory. Very cool. We are representing. All right, let's try and wrap this up. We're getting about 25 minutes into it. But let's first of all create a new JSON file. We're going to create our first character. So I'm going to say add, I'm going to say new file. And where's JSON? It's here somewhere. JSON file. You can make it a text file and save it as JSON, but whatever. And remember, here's our JSON structure, right? So you got these brackets, all this stuff. So I'll bring it over here. Actually, let's put it back over here. I'm gonna name this file. I'm gonna save JSON1 as. Now check this out. I'm gonna put this in the bin. See, we got adventures. Let's make a folder for characters in the bin.NET Core. Characters. And I'm gonna call him Conan. .json. That's the name of our guy. That will be our initial character that we pull out if they don't have characters or they don't want to make a character. If they want to use a standard character, so we'll call him Conan. So we need to make this mirror this so that when we open it up and we load it up, it all looks the same. So we'll go name Conan. Right. We'll go a level. And that's an int, so we can't make it a string. So he's level 1. I know he's not really level 1, but you know. So abilities, let's leave that out for now. I want to wrap this up. We can do that in a little bit. Gold, he's a pauper. He's a young thief, so he's got 2 gold. Adventures played. Bool is alive. This is dumb. Bool is alive. I mean, if you've got hit points, we didn't put hit points. That's ridiculous. Public int so hit points, he's gonna have 4. And did we choose a class? We didn't do classes either. All right, we'll make him a thief. We'll do it later. And so there's an easy, quick representation of Conan. We're going to save that. And so really quick, this should be super easy. We're going to follow the pattern that we do with adventure services. So we're going to have a character service. We need to have a character folder. Add folder. Characters, all things characters go in here. No, that's not right. We already have entities. We'll just put it all in entities. So in entities, we'll create a character service. Add a class, call it character service.cs, just like adventure service, right? So we got an adventure service. Oh, so we need an interface. So I need an iCharacter service. And iCharacter service, I'll do public interface. And we're going to want to send back a character. So we'll do public character. And it's called load initial character. Just like load initial adventure. So there we have one method. Let's clean up these using statements. We're not going to use these. So back over here on our public character service. We're going to say this is going to implement the iCharacter service interface, and it's screaming because we're not doing it right now. So I need to say public character load. You guys know I could do this easier, right? If I could have right-clicked it over here, use the light bulb, and had it do this for me, but I didn't. So boom, boom. And all right, so adventure service. Remember, let's jump to adventure service and see how we did this. This is gonna be super similar. We could take all this stuff right here, copy it, bring it right back over to this one. All right, with a few changes. Let's spread this out. We're not in adventures anymore. We're now in characters. Initial, we're going to say Control RR, which is rename. We're going to say initial character. You do that, and that will rename all the other instances. So it renamed all the other instances for us. And this needs to be a character. And file exists. We need to bring in a using statement of using IO. JSON convert. We need our JSON Newton sauce for JSON. So let's see, it's not initial JSON, it's Conan JSON. Has a direct path, again, Conan JSON, because now we make sure it exists, then we open it, and then we deserialize it as a character, right? And then we return the character. So that's it, we're done. We've that fast, guys. Now that we have this in place, we're getting that fast. Let's get rid of the using statements that we don't need. All right, so now let's go over to our game engine. Our game service, I'm sorry. And so when we start game, we need an initial adventure. We also need an initial character, right? So initial character. If you're paying close attention, you might see something wrong. I don't have character service in here. So I got to change this. I need to make private character service. Character service. We do lowercase for privates. You can do underscores for private names. I don't like that. That's an older school. So uppercase for publics or for arguments. I'm going to say character service equals character, the one that you sent in. Oops. Character service. There we go. Now we have one here. Now we can say character service dot get. All right, so we got something wrong. Character service should be showing our. Have I saved everything? I haven't saved everything yet, so let's just do that. There he is. Load, not get. Load. Load initial character. I should have called it get initial character. That would be better. We'll change that later. All right, now that we have initial character, let's write a couple more right lines to make sure that we actually got a real character. This will be cool. So I'm going to say character name right, dot name, and something else about Mr. Conan. Mr. Conan. He likes to be called Mr. Conan. Level. Right, and we'll say and let's put a breakpoint here just so we can see it. And then one last thing we're going to need to do is go to our main program, and we got to pass this stuff in. It's going to break. So I'll take all that, copy it. Character service. That's missing. I got a using statement. There's my using statement. I'm going to call this character service, right? If I can type. And it is a character service. And now I can pass this in. Nice. Now everything should work. We should be getting that fast. Now we're getting set up. We should now have a character and an adventure. Let's roll. Let's see this. I just worried that I wasn't recording. That would be terrible. All right, start a new game. All right, we got a break, stop. Let's hit load initial character. And what do we have? Do we have a real character? There he is, Conan, level 1. Hit points 4, gold 2. All these other things are null because we didn't fill them in. But yeah, we hit F5, go back to our thing, and There's Conan. He's level 1. All right, guys. So, guys, you learned a ton of things tonight. That's it for this evening. Well done. You learned about Liskov, about branching, about inheritance, about interfaces. And yeah, we are really ready to start working on the actual game pieces. Now we got all the basic pieces, and now we can start working on the game logic and start playing the game. See you next time. Appreciate it.